NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again. In the universe, we have no idea what it is, but we can measure it. Voyager 1, the iconic space probe launched by NASA over 4.5 decades ago, has just sent back a signal that has sent shock waves through the scientific community. After traveling nearly 14 billion miles from Earth, Voyager 1 has made a discovery so profound that it has altered the course of its mission, turning back towards our planet. But what exactly could this discovery be? Could it be evidence of extraterrestrial life, a cosmic anomaly, or something even more unimaginable? In this gripping exploration, we'll unveil these shocking revelations as Voyager 1 has just made a terrifying discovery that made it suddenly turn back towards Earth. The Voyager twin probes, if certain celestial events hadn't coincided, two of the most remarkable spacecraft ever launched, might never have left Earth. In this case, the aligning stars were the four largest planets in our solar system. About 60 years ago, these planets were slowly aligning in a way that had last occurred during Thomas Jefferson's presidency in the early 19th century. This rare planetary alignment went largely unnoticed at first. The first person to recognize its significance was Gary Flandreau, a doctoral student in aeronautics at the California Institute of Technology. Back in 1965, when space exploration was just beginning, working part-time at NASA's Jet Propulsion Laboratory in Pasadena, California, Flandreau was tasked with figuring out the most efficient way to send a space probe to Jupiter or even farther out to Saturn, Uranus, or Neptune. Using a simple pencil, he meticulously plotted the orbital paths of these giant planets and made a fascinating discovery. In the late 1970s and early 1980s, all four planets would align in a way that they could be visited in a single mission. This alignment meant that a spacecraft could use the gravitational pull of each planet to slingshot itself to the next, significantly reducing travel time. Flandreau calculated that this alignment would cut the flight time from Earth to Neptune from 30 years to just 12 years. However, there was a catch. This planetary alignment only occurred once every 176 years. To take advantage of this rare opportunity, a spacecraft would need to be launched by the mid-1970s. NASA seized this once-in-a-lifetime chance and built two spacecraft to make the journey. These spacecraft, Voyager 1 and Voyager 2, were sent on an incredible mission to explore the outer planets of our solar system. Thanks to the alignment of the planets and the visionary calculations of Gary Flandreau, the launch of the Voyager twin probes on September 5, 1977, marked something truly incredible happening at Cape Canaveral in Florida. Voyager 1 embarked on its epic journey into space, lifted off by a mighty rocket known as Titan IIe Centaur. Just 15 days after Voyager 2 was launched on August 20, 1977, Voyager 1 joined the cosmic adventure, beginning its voyage into the vast universe by following a shorter trajectory. Their primary mission was to explore the massive gas giants in our solar system, such as Jupiter and Saturn, along with their numerous moons. However, these intrepid space travelers surpassed all expectations. They ventured far beyond, pushing the boundaries of exploration, traveling farther and longer than any other spacecraft in history. They broke numerous records on their inspiring odyssey. They have journeyed beyond anything created by humans before, even venturing into a region known as interstellar space, a completely uncharted territory within our galaxy. These trailblazing spacecraft, Voyager 1 and Voyager 2, are now more than 12 billion miles away from us. Despite their immense distance, they continue to astonish scientists with the remarkable discoveries they make out there. Most recently, they have made a discovery so unexpected that it has taken everyone by surprise. The Voyager twin probes have achieved some truly remarkable feats. Over 40 years ago, they scrutinized the moons of Jupiter and Saturn, astonishing scientists. Initially believed to be dull and pockmarked like our moon, these moons turned out to be vibrant hubs of activity. Voyager 2 made history by becoming the first of the twins to swing by Uranus in 1986, and just 3 years later, it zipped past Neptune, a feat unmatched by any other spacecraft. As these spacecraft continue their incredible journey, NASA employed some clever strategies to ensure they remain operational. They've deactivated non-essential components, such as spare parts and heaters, to conserve power. This strategy aims to keep the spacecraft running smoothly until at least 2030. For the dedicated scientists and engineers who have been part of this extraordinary adventure from its inception, it's a bittersweet mix of emotions. Their hard work has paid off, and just when they thought the Voyager missions were nearing their end, a stunning discovery emerged from the depths of outer space. For decades ago, the Voyager spacecraft amazed researchers by providing the first up-close views of the moons of Jupiter and Saturn. These moons, which astronomers had believed to be dull and heavily pockmarked like our own moon, turned out to be vibrant worlds. Voyager 1 reached Jupiter in March 1979, just 546 days after its launch. Voyager 2, following a slightly different path, arrived in July of the same year. Both spacecraft were equipped with Vidicon cameras that used filters to capture full-color images. Interestingly, they were designed to be very stable, spinning through space at a rate more than 15 times slower than the hour hand of a clock. This ensured that the images they captured were clear and sharp. During their mission, the Voyagers took more than 33,000 photographs of Jupiter and its moons, each revealing new and fascinating details. For instance, Europa, one of Jupiter's 53 named moons, was found to have a cracked icy crust estimated to be more than 60 meters thick. As the spacecraft departed from the Jupiter system, they received a farewell boost in speed of 35,700 miles per hour from a gravitational slingshot, a crucial maneuver that helped propel them towards interstellar space. At Saturn, the Voyagers went their separate ways. Voyager 1 passed through Saturn's majestic rings, enduring thousands of impacts from tiny dust particles before flying past Titan, a moon enveloped in an orange haze, and heading northward out of the plane of the planets. Voyager 2 continued its solitary journey, reaching Uranus and Neptune in 1986. During its visit to Uranus, Voyager 2 discovered 10 new moons and added the planet to the list of worlds in our solar system with rings. However, Voyager 2's achievements were overshadowed by tragedy. Just 4 days after its closest approach to Uranus, the Space Shuttle Challenger tragically exploded shortly after liftoff, claiming the lives of all 7 crew members, including Krista McAuliffe, a high school teacher from New Hampshire who was set to become the first civilian to travel into space. 3 years later, as Voyager 2 soared about 2,800 miles above Neptune's stunning azure methane sky, it encountered the swiftest winds recorded on any planet in our solar system, reaching speeds of up to 1,000 miles per hour. Neptune's largest moon, Triton, turned out to be one of the coldest spots in our cosmic neighborhood, with surface temperatures plummeting to a staggering -235 degrees Celsius. The moon's icy volcanoes were another remarkable find, ejecting nitrogen gas and fine particles up to 5 miles into its atmosphere. After Voyager 2's mesmerizing images of Neptune and its moons, both spacecraft were scheduled to power down their cameras, marking the end of their official mission. However, astronomer Carl Sagan, a member of the mission's imaging team, intervened. Despite the grand tour technically concluding, NASA had extended the mission with hopes that the Voyagers would venture into interstellar space. Renamed the Voyager Interstellar Mission, the spacecraft were set to continue their journey into the unknown. Sagan persuaded NASA to let Voyager 1 take one last series of images. On Valentine's Day in 1990, the spacecraft turned its cameras back toward the inner solar system and snapped 60 final shots. One of these images, famously referred to by Carl Sagan as the pale blue dot, captured Earth from a staggering distance of 3.8 billion miles. In the picture, Earth appears as a minuscule speck, barely visible against the vastness of space, illuminated by a faint glimmer of sunlight reflected off the camera's optics. We've learned so much about the planets and moons in our solar system. It's exciting to see how unique and fascinating each one is, even those that are farthest away. Voyager 1's journey beyond the heliosphere in August 2012 marked an incredible milestone. By venturing beyond the heliosphere, a vast region of charged particles emitted by the Sun, Voyager 1's remarkable feat became widely known the following year when a study was published in the journal Science, sharing Voyager 1's groundbreaking discovery. The spacecraft's plasma wave instrument detected a powerful solar eruption between April 9 and May 22, 2013. This event caused electrons near Voyager 1 to vibrate, indicating that the spacecraft had entered a region of higher particle density than that found just inside the heliosphere. At first glance, It might seem surprising that the electron density is greater in interstellar space than near the Sun. However, researchers explained that the electron density at the heliosphere's edge is significantly lower than at Earth's surface. Analyzing Voyager 1's data, researchers pinpointed the official departure date as August 25, 2012. This determination was not based solely on electron oscillations but also on measurements of charged solar particles collected by the spacecraft on that significant day. Coincidentally, this was also the day that the renowned Apollo 11 astronaut Neil Armstrong, who famously became the first person to set foot on the Moon, passed away. As the first spacecraft to reach interstellar space, Voyager 1 accomplished a groundbreaking feat with its durable construction. The spacecraft endured the harsh conditions of the solar system, withstanding radiation levels and other hazards that would have severely harmed humans. Both Voyager 1 and its twin, Voyager 2, were built to last, and their impressive longevity has amazed everyone. Currently, Voyager 1 is approximately 12 billion miles from Earth, with Voyager 2 close behind at about 10 billion miles away. Due to this immense distance, the signals they transmit take over 17 hours to reach our planet, despite traveling at the speed of light. From their current position, the Sun is not the bright, yellowish-white disk we see from Earth. Instead, it appears as a small, dim speck in the vast expanse of space. Even so, the Sun continues to have an effect on the Voyager spacecraft. According to Susan Dodd, the project manager for the Voyager missions at NASA's Jet Propulsion Laboratory, both spacecraft were designed to operate on a nuclear battery. The generator on board generates heat through the decay of radioactive plutonium, which is then converted into electricity to power the onboard instruments. As the spacecraft continues to move away from Earth, the amount of energy produced by this process decreases. Despite this, the generator's longevity has been impressive, powering the spacecraft for an extended period. This is especially remarkable given that Voyager 2 is the first spacecraft to directly study the region where the heliosphere meets interstellar space. As the energy supply gradually diminishes, scientists will have to make tough decisions about which instruments to keep running and which ones to turn off. However, in an unexpected turn of events, NASA recently shared exciting news. Voyager 1, the most distant human-made object, which had been experiencing communication issues for several months, suddenly began transmitting data again, sparking a wave of excitement among scientists. NASA's Voyager team was amazed to discover that despite traveling through the hostile environment of interstellar space, the spacecraft's high-gain antenna had spontaneously reset and resumed transmitting data. This development brought much-needed relief, as the spacecraft was previously sending back garbled data. In a detailed press release, NASA explained that the spacecraft had been facing challenges. A device that measures the spacecraft's orientation in space, a crucial component for accurately pointing the high-gain antenna towards Earth, had been malfunctioning. This caused Voyager 1 to send back jumbled information, leaving scientists puzzled. To understand what was happening, engineers had to investigate whether the issue lay with the antenna or the equipment providing orientation data to the antenna. The remarkable turnaround came when Voyager 1's antenna started transmitting clear and accurate data again, much to the team's delight. While the scientists are still trying to determine the root cause of the issue, they are grateful that the spacecraft has regained its functionality and continues to provide valuable data from the far reaches of space. Voyager 1's recent unexplained behavior adds to the many surprises and mysteries these iconic spacecraft have encountered throughout their journey. From the grand tour of the outer planets to venturing into interstellar space, the Voyager missions have been a treasure trove of discoveries. As they continue their journey into the unknown, scientists eagerly await the next set of data and revelations from these intrepid explorers. Their remarkable voyage reminds us of the boundless curiosity and ingenuity that drive humanity to explore the cosmos. What they find next is anyone's guess, but one thing is certain. Voyager 1 and its twin, Voyager 2, will forever be remembered as trailblazers in our quest to understand the universe. As Voyager 1 continues to move away from Earth, it remains a testament to the power of human curiosity and exploration. The spacecraft's ongoing mission is a reminder that there is still so much to learn about our solar system and beyond. And with each new discovery, we are one step closer to unlocking the mysteries of the universe.